Here we have a system of equations with three equations and three variables. And once we get to that point, uh, I prefer to change this to a matrix. That way we don't have to continue to write these variables. It's just a simplified form of doing so. So all we take are the coefficients of the x, y, and z, and then the value of the constant to the right of the equal. Be sure when you create your matrix, they are all in order, right? We have all x's here, we have all y's here, z's, and then the constants up over here, right? So we set this up as a matrix 4, 4, -4, and then usually we draw either a dashed line or solid line. It really doesn't matter. We separate to show that those are the values on the right. 2, -1, 1, -9, 1, -2, 3, 1. All right, now some people in matrices do a bracket, some do a brace, parenthesis. It really doesn't matter. Okay, we know this is a matrix. All right, our goal, so notice like it's still in line with columns, right? It just eliminated right into x, y, and z. And our goal is to transform this thing into a bunch of ones and zeros, which we call reduced row echelon form. So what we want is 1, 0, 0, and then whatever number is here is our answer. Okay, I'll explain better here in a second. 0, 1, 0, 0, 0, 1. Okay, because if I had this matrix in reduced row echelon form, and I rewrote it back with x's and y's, really this says x, 1x, right, plus 0y plus 0z equals whatever that number is. Okay, we'll call it number 1 because they might be different. And then the second row, these are rows, right? These are columns. And our second row says 0x plus 1y plus 0z equals some other number. Maybe it's the same, maybe not. Okay, and the last row, likewise, 0x, 0y, and 1z equals that third number. So essentially, if you can get it down to this form, you have your answers. You have your x, y, and z. There are a few operations that are allowable. The first one I'm going to use right away, we are allowed to swap rows. Because swapping a row is really just writing the problem in a different order, right? So like, if I move this third equation to the top, I didn't change the problem at all. And that's what I'm going to do first. We're going to swap row 1 and row 3. Okay, R1 with R3. That's what I'm going to do first. So let's go ahead and write that. 1, -2, 3, 1. Second row I'm leaving alone. Third row, 4, 4, -4, 24. Okay, that seems allowable. Another thing we are allowed to do, just like system of equations before, right, when we were writing all these equations, when you go for the elimination method, what you do is you multiply certain values and add together the rows. So that's what I'm going to do here. Again, our goal is to get a 1 here. I mean, I want all ones in the diagonal, but in order, you work by column. Okay, I have a 1, so next I need 0, 0. All right, that is your first goal. Work in columns. Or work by columns, okay? So if I multiplied -2 to row 1 and added that to row 2, I could get a 0, right? So what does that look like? Well, if I were back to the original, if I multiplied all these by -2, so this would be +4, and -6 and -2. And then I took those and I added them together, right? These two here. 2x minus 2x, 0. Negative y plus 4y is 3y. Z minus 6z, and then I have -9 and -2. So I eliminated the x's. That's what I'm doing here. But we're going to do it, it's up to you. How I like to write it is -2. Let me do this in green just to stay consistent. And over here, I'm going to do -2 r1 plus r2. I'm writing that here because that's where I'm leaving it. Likewise, I'm going to do -4 r1 and add that to row 3. It's easiest to work with the element that has a 1. Okay, so when I mean element, I mean the first row, first column that has a 1. I'm going to manipulate that to get these other guys to zeros. Okay, so how I like to write that is I know I'm going to do -2 times row 1, so I just write those values here. That way when I add them, I could see right away, right? I'm just adding those two values. And we should get what I got over here. But I'm not going to write that each time. Like it's cumbersome. It's just to show you what is happening. All right. Now, -4 row 1, so this is -4. This would be +8. -4 times 3 is -12. Hopefully I don't mess up my arithmetic because that is common. All right, so those are how it's going to look. Row 1 is not changing. So I have 2 minus 2, 0, -1 and 4 is 3, and 1 and -6, -5, -9, -2, -11 is, which is exactly what we got over here, so that's good. 0, 12, -16, 20. If you need to pause, rewind, that's a great thing about video and not a live lecture. You can do that. All right, now next goal. We want to get a 1. Okay, we're going for, we got 1, 0, 0, we're working by columns. We want a 1 right here. So I forgot to write all the rules, but I kind of intentionally did that because the second thing you're allowed to do is you could divide or multiply, right? Same thing, division is the inverse of multiplication. Any row by any value you want. Okay, multiplication or division of a constant is allowed. I should say by non-zero. Okay, that would be not unexciting anyways. So what are we going to do? We're going to multiply row 2 by 1/3, or like I said, multiply or divide, right? Same thing, or divide everything by 3. So sticking with consistency here, I'm going to take 1/3 multiplied by row 2. Okay, let's go ahead and rewrite that now. 1, -2, 3. Row 1 does not change. 0 multiplied by 1/3, 0. 3 multiplied by 1/3, 1. -5 multiplied by 1/3, -11 multiplied by 1/3. And then row 3 is not changing. Okay, not yet at least. Now the third operation we're allowed to do, which we already did above, is we can combine two rows, and it could be a multiple of that row, right? We can combine any rows, combine rows, so by combine I mean add, and multiples of those rows. Well, usually we're just taking the multiple of one of the rows, right, this one, and adding the other. So if I multiplied row 2 by 2, row 2, and added it to row 1, I would get a 0 here. If I multiplied negative 12 to row 2 and added it to row 3, I would get a 0 here. That's my goal. Unfortunately, we have some fractions. It's all right. They're a pain, but intermediate steps were not promised to be pretty in here. So let's check it out. 2 times row 2. So this would be a 2, right? 1 times 2, negative 5/3 times 2 is negative 10 over 3, and then negative 22 over 3. So those are what I'm going to add to my row 1. Negative 12 times row 2, so negative 12. Ooh, well, the good news here, we do get some fractions to cancel. I'm going to write this off to the side. So we get negative 4 times negative 5 is 20. I like that. And then negative 12 times 11/3, we can cancel, and we get positive 44. All right. I should be placing equals each time because really, right, each operation, we get a new matrix. It's equivalent, just looks different, right? We're manipulating all the coefficients. Negative 2 and 2 is 0. 3 and negative 10/3, so I need LCD. 3 is 9 over 3, so that would be 9 over 3 minus 10 over 3, negative 1/3. 1 is 3 over 3 minus 22, so negative 19/3. 0, 1, negative 5/3, negative 11/3. 0, 12 minus 12, 0. Almost done. Negative 16 and 20 is 4, 64. All right. Recall our next goal, right? We're going for row 3. We want that 1 first. Work in columns, and I should even star that and say get the 1 first. So divide by 4 or multiply by 1/4. The other rows are not being touched yet. The more practice you get, you could start, trying to combine a couple steps into one, but I really don't want to mess up, especially while recording. 4 and a 64, I think, is 16. Okay, so we have one result. Right here, I know Z is 16, right? But we're doing a matrix. I want to go the whole way. Like, let's finish this matrix and get reduced row echelon form. So why I did write this, though, is you could go back and substitute, right? On the next line, we have, if I know Z, I have Y minus 5/3 Z equals negative 11/3. I can plug that in and find Y. But we're going to take it the whole way. All right, I need to multiply row 3 by 5/3 and add to row 2 to get this to be 0. I need to multiply row 3 by 1/3 and add to row 1 to get that to be 0. So we would have, let's do the top row first, 1 times 1/3, and 16 times 1/3 is just 16, add 16/3. Okay, 5/3 times 1 is 5/3. 16 times 5/3, oh, I don't know. 16 multiplied by 5/3 is 80, 80 over 3. All right. So close. 1, 0, 0. And we have our x. It is negative 19 thirds plus 16 thirds is negative 3 thirds, right? Which is negative 1. Our next row, we have 0, 1, 0. Oh, 80 minus 11 is 69 thirds, which is 23. Okay, so just as a reference, I did, right, all I was doing is adding these, negative 11 thirds plus 80 thirds, 69 thirds, which is division, and you get 23. Okay, and the last row we were already done. So we have our solution. We have x is negative 1, y is 23, z is 16, or right, written as a ordered triple, negative 1, 23, 16. That is our solution. I'm not good at graphing 3 dimensions and these planes that would intersect. No thank you. So I would much prefer the matrix method. However, I'm going to show you a cool piece of technology. I now saved the best for last, right? What a cheater I am. So in GeoGebra, there's a link, and pause your video to see it. It has a backslash MP8XP32KZ. Uh-oh, there we go. Oh no, it erased it. That's okay. Showing it from the start, this is an awesome find anyways. We can adjust our rows and columns. Oh, it had exactly what I wanted. Just showing you could adjust that. And you don't even have to change any of your the orders that they're in or anything. Just enter all the data exactly as you have it. So I am just typing. Unfortunately, I erased it, but that's fine. Type all the original equations you have in matrix form, right? This was our start. This was the beginning of the matrix we had. Now you can do various things with this, but you hit set matrix. And what I'm after is showing the reduced row echelon form. Done. Negative 1, 23, 16. I love technology. We could do other things to it and whoops, change rows or multiply scalars, like all the work I had done. But one click and you have your answer.